Have you ever asked an AI about something that happened yesterday, only for it to confidently give you the wrong answer? This is the knowledge cutoff problem. Even the smartest models are frozen in time based on their training data. Today, we are going to fix that using Retrieval-Augmented Generation. Think of an LLM as a brilliant student taking an exam. Without RAG, they are relying purely on memory. With RAG, we are giving them an open book exam. We provide the textbook, and their job is to find the right page and summarize it for us. This makes the AI factual and verifiable. So how does this actually work under the hood? It is a four-step dance. First, we take your data and turn it into math. Then, we store it in a special database. When a question comes in, we search for the most relevant facts. Finally, we hand those facts to the LLM to generate the answer. Before we can search our data, we have to talk about embeddings. Computers do not understand words like apple or justice. They understand numbers. An embedding model takes a sentence and turns it into a long list of numbers, which we call a vector. This vector represents the meaning of the text. Now, here is where it gets cool. Imagine a giant 3D space. Words with similar meanings are placed close together. King and queen will be near each other, while apple will be far away. This spatial relationship is how the computer understands that two different sentences are actually talking about the same thing. To find the best matches, we use a concept called Cosine Similarity. Do not let the name scare you. It is just a way to measure the angle between two vectors. If the angle is small, the meaning is similar. If the angle is 90 degrees, they have nothing in common. It is like checking if two arrows are pointing in the same direction. Watch out for this common mistake. You might think we should measure the distance between the points, like using a ruler. But in text, the length of the vector often just represents how many words are in the sentence. That is why we use the angle, or cosine similarity, instead of the straight line distance. Direction is meaning. Once we have our embeddings, we need a home for them. This is the vector database. Unlike a traditional database that looks for exact words, this database looks for neighborhoods of meaning. It allows us to search through millions of documents in milliseconds to find the exact chunks of text that answer our query. Now, let us look at the retrieval step. When you ask a question, we turn your question into a vector too. Then we perform a top K search. This means we grab the K most similar chunks of text. Usually, we take the top 3 or 5 most relevant pieces of information to give to the AI. Wait, there is a catch. If your data chunks are too small, they lose context. If they are too big, they contain too much noise. This is called chunking strategy. We often use overlapping chunks to make sure no important information falls through the cracks between two pieces of text. Next is augmentation. We do not just send the question to the LLM. We build a prompt sandwich. We tell the AI, here is some context. Here is the question. Use the context to answer the question. This forces the AI to stay grounded in the facts we provided. Finally, we reach generation. The LLM reads the context and the question and produces an answer. Because we gave it the source material, it can even provide citations. It can say, according to document A, the answer is 42. This eliminates hallucination and builds trust with your users. But wait. What if the search results are not perfect? Advanced RAG uses a re-ranker. First, we grab 100 possible matches quickly. Then, a more powerful model looks at those 100 and picks the absolute best 5. It is like having a fast assistant find some files, and then a senior expert picking the best ones. In an agentic system, RAG becomes a tool. An AI agent can decide when it needs to search the vector database and when it already knows the answer. It can even perform multiple searches, gathering information from different sources before synthesizing a final complex response. This is the peak of current AI capability. So, we have covered the why and the how of RAG, from turning words into vectors to building factual, open-book AI systems. Remember, an LLM is only as good as the data you give it. Master these components, and you can build AI that is not just smart, but truly reliable. Now, go build something amazing.